Hi friends, my name is Vivekanandan. I am student of Sri Venkateshwara College of Engineering, Bangalore. In this video, I am going to discuss about software and software engineering. Let's see contents. Introduction to software and software engineering. The nature of the software. The unique nature of web apps. Software engineering. The software process. The software engineering practice. The software might. How it all starts. Process models are generic models. Process assessment and improvement. Now let's see introduction to software and software engineering. Software and software engineering are the foundations of the digital world we live in. From the apps on our phone to the website we visit, software powers our daily lives and enables businesses to operate. Understanding the unique nature of the software and the principle of software engineering is crucial for anyone looking to create innovative digital solutions. Now let's see the nature of software. Intangible. Software is an intangible product existing as a line of code and instruction rather than a physical objects. This makes it inherently different from a traditional engineering disciplines. Malleable. Malleable software can be easily modified and updated, allowing for rapid iterations and continuous improvement. This flexibility is both blessing and a challenge for a software engineers. Complex. As a software system grew in a size and functionality, they become increasingly complex, making them harder to design and develop and maintain. Ubiquitous. Software is now embedded in nearly every aspect of our lives, from our personal device to critical infrastructures. This is a ubiquity and underscore the importance of the software quality and reliability. Now let's see unique nature of web app. Accessibility. Web applications are accessible from any device with a browser and allowing for a much wider reach and more diverse user base compared to traditional desktop software. Continuous deployment. Web apps can be updated and deployed continuously without the need of user to manually install update. This allows for a rapid iterations and bugs fix. Scalability. Web apps can easily scale to accommodate large number of users and traffics thanks to distribution nature of the web and cloud-based infrastructure. Now let's see software engineering. Planning. Software engineering begins with the throwing through planning and requirement gathering to understand the problem at hand and define the scope of the project. Design. The design phase involves creating a detailed blueprint for the software, including its architecture, user interface, and key functionality. Implementations. Actual coding and development of the software where the design is brought to life through program languages and tools. Now let's see the software processes. Requirement gathering. Identifying the needs and goals of the software and gathering input from stakeholders and defining the project scope and objectives. Design. Creating the architectural blueprint for the software and including the user interface, data structure, and the system components. Implementations. The actual coding and development of the software where design is brought to life through programming language and tools. Testing. Thoroughly testing the software to ensure it meets its requirements and is free of defects before deployments. Deployment. Releasing the software to the end user either through a one-time launch or series of incremental updates. Maintenance. continuously monitoring and maintaining and updating the software to address any issues or new requirements that arise. Now let's see the software engineering practice. Teamwork. Software engineer is a collaborate effect requiring strong communication and coordination among team members with diverse skills and roles. Agility. Embracing an agility mindset and iterative development process allows software teams to respond quickly to changing requirements and market demands. Continuous improvement. Software engineering is an ongoing process of learning, experimenting, and refining practice and technique to improving the quality and efficiency of software development. Tools and automations. Leveraging a wide range of tools and automation to today's tasks can greatly enhance the productivity and effectiveness of the software engineering teams. Now let's see the software myths. Software is easy. Developing high quality software is a complex and challenging process that requiring a deep understanding of technology and design and the problem domain. Software can be rushed. Trying to rush the software development process often to lead to shortcut bugs and poor user experience and patient and carefully planning are key. Software requirements are fixed. Software requirements are constantly evolving and successfully project embraces these changes rather than trying to lock down requirements from the start. Software engineering is purely technical. Effective software engineering requires a balance of technical skill and problem solving and communication ability to deliver solution that meets user needs. Now let's see how it all starts. First, idea generation. The software development process often begins with a spark of inspirations and idea for a new product or solution that could solve problem or improve people lives. Feasibility assessment. The next is to create carefully evaluate the feasibility of the ideas and considering factors like a market demands and technical viability and the resource requirement to bring the idea to life. Planning and idea design. If the idea is deemed viable, the software engineering team can begin planning and design phase, laying the groundwork for actual development works. Now let's see processes model, a generic process model, requirements, gathering and understanding the software requirement including the needs of the users and stakeholder and the problem of the software aims to solve. Design. Designing the software architecture, user interface and key functionality based on the identified requirements. Implementations. The actual code and development of the software where the design is brought to life through programming language and tools. Testing. Thoroughly testing the software process to ensure that it meets its requirement and is free of defects before deployment. Deployment, releasing the software to the end user either through one-time launch or series of incremental updates. Maintenance, continuously monitoring, maintaining and updating the software to address any issues or new requirement arise. Now let's see process assessment and improvement. Process maturity models and the software engineering organization can assess their process maturity using established models like Capability Maturity Model Integration. Let's call in short form CMMI, which provides a framework for continuous process improvement. Data-driven analysis by collecting and analyze the data on projecting performance, team productivity, and customer satisfaction. Software teams can identify areas for improvement and making a data-driven decision about the process changes. Experimental mindset. Embarrassing an experimental mindset, software engineer teams can test and iterate on a new process improvement, continuously learning and adapting their practice to become more efficient and effective. Thank you.